And here we have this SDF, so now we just have to read it directly from disk and it will load super fast in our Pyro simulation. So let's drop down a null here and this will be SDF call, and I will grab this and just bring this down below over here. So let's do an object merge, bring in the SDF and place this here where it says, so in our second input, which is going to be for the collisions. Let's reset the simulation. And in the collision tab, we will switch the type here to SDF plus volume velocity. Now we also could have generated this velocity volume, but since our velocity field itself is making our smoke move really fast, I found that having this extra volume from our geometry didn't really help that much. So it was honestly kind of a waste of time setting this up. So this is why we are only using the collision volume. Okay, so let's press play and check if our collision is being detected. And this will be hard to tell until our hand is gonna reach for the ground, but I think we can already start to see that something's happening over here. If we want to double check that this is working, we can always step inside our Pyro Solver and this will give us this blue outline of our SDF, and we can see, or rather our collision, and we can see that this is indeed working and we should be fine for our collision. So I can also play this and we can see that the smoke is wrapping around our arm and our snow geometry. So this is what we want. All right, and let's go up and let's play this in real time, and we can kind of see a shadow here where our hand ends up being and getting dragged. So I believe this will be fine for our Pyro simulation. Let's go ahead and increase the resolution. So we are going to do 0.05 here. We don't need to go super high because we are just using this to advect particles. If you want more swirls and more detail in general, you can go ahead and increase the voxel size here. So you can use something like 0.025. But in this case, since I did want kind of a smoother result, or rather a smoother movement for the particles, I decided that a lower resolution was actually better. So let's go ahead and do a file cache. I will set this to my job folder and this will be our Pyro vel. And before we simulate, there's one thing that we have to take into consideration here, which is that if I go to this Pyro Solver and go back here, we need a few frames of pre-roll. So we need this smoke to be already on the screen. So at our frame 1, we need to already have smoke filling up the screen. And we can see that the smoke only starts to really fill up the screen, maybe if I go forward 50 frames. We can check and see now that we do have enough smoke to cover the screen, especially if I look through the camera. We probably need to start with the pyro simulation in this state. So we need 50 frames of pre-roll in this case. So what we want to do is delay the animation for our collision. So if we go to our SDF, we need to delay this by 50 frames. So we have to let the pyro simulation run for 50 frames. So we start at the first frame of the animation with smoke already on the screen, and only after 50 frames we have to play this animation. So what I'm gonna do is I'm just gonna create a null, and I won't attach this to anything. I just want to store this pre-roll value with this null, and let's rename this to pre-roll. Just because we have to reference this value in multiple different places. We can also press C and just make this a different color, and if I press Z, we can give this a different shape as well. So maybe I can use something like this just to differentiate this a bit from the other nulls that we are using. I actually ended up choosing exactly the same icon here. Let's go with something like this, so the circle. And here I will go to this cogwheel. Let's choose edit parameter interface, and I will just grab a float and place it in my root folder. And let's rename this to pre-roll, and also this pre-roll for the name. Let's hit accept and let's set this to 50 frames. And the first thing that we have to do is delay our animation. So let's do a time shift after our file cache. And we are going to subtract from our frame expression this pre-roll value. So let's go here, right click, copy parameter, go to the time shift, and here we will say $F minus and then paste relative references. So now this will only start animating at frame 50, and we also run into a problem here, which is that we don't have anything before frame 50. And we can fix this by setting this clamp value here. Let's do clamp to first. So now this will hold the animation at the first frame if we go in the negative ranges here. So if we are at frame 0 and then -10, it's always going to reference this first frame. And then after frame 50, this will run as it should. So now we can run our simulation. And when we do our file cache, we also have to account for this 50 frame difference here. So we have to save an extra 50 frames on top of the original frame range that we have. So over here for our second value, so for our end range, let's go to the expression, and here we are going to add the same 50 frame value. So let's hit plus, right click and paste relative references. So in total now we are simulating 242 frames. So let's go ahead and save to disk, and here we have the simulation with our delayed collision. So we can drop down a null from here, and this will be our pyro val. And now we can advect our particles, and after we do our particle simulation, we will just have to push that animation forward in time 50 frames so it matches our actual animation. And we will see this in a second.